So our video covered the difference between foiling and the double distributive property. And the truth is, most of the time, you're always going to get the same answer. But the double distributive property is better if you are doing a binomial times a bigger polynomial, like what we had at the end of the last video. But as a quick review, let's go through what foiling is and what the double distributive property is. So for this problem, foiling would be the first term in each parenthesis, which would be 8x squared if we multiplied them together. The outside terms would be 4x times negative 1, or negative 4x. The inside terms would be 6 times 2x, which would be positive 12x. And the last terms on each would be positive 6 times negative 1, which would be negative 6. Normally, you have to simplify these problems when you are done, and this is no different. Negative 4x and positive 12x simplifies to be 8x. So I would write 8x squared plus 8x minus 6 if I was writing this in descending order. Now, for the double distributive property, which is the way that I solve these problems, I look at my first number in the first parentheses, and I distribute the 4x to every term in the opposite parentheses, which would give me 8x squared minus 4x. Then I distribute the next number to every number in the opposite parentheses, which would give me positive 12x minus 6. And because I have distributed every number in the first parenthesis to every number in the second parenthesis, I am done. And if I notice, these two steps are identical. They're actually even written in the same exact order, which is why I prefer the double distributive property over foiling, because foiling only works for a binomial times a binomial, where the double distributive or triple distributive or quadruple distributive property can work on any polynomial times any other polynomial. Let's do a couple quick examples. This problem right here, I'm going to do a different method for each of these. Now there we go. I'm going to do foiling for this first problem, okay? So foiling, so the first term is 4y times 4y, which would be 16y squared. The O, or outside, would be 4y times positive 1, which is positive 4y. The inside term will be negative 1 times 4y, which is negative 4y. And the last term here would be negative 1 times positive 1, which is negative 1. I can combine the middle terms here, and don't be fooled, these do create a 0. So I end up getting 16y squared minus 1, because this term can be ignored. I would not write 0y here. So that is foiling. The double distributive property is the exact same process. Well, we got to bring down the parenthesis here. So for the double distributive property, I look at the first number in the first parenthesis, and I distribute it to every number in the next parenthesis. Now, for the first time, we have different variables here, but the process is the same. So I get x squared times y. If we remember from our last video, we can't combine them, so they can just stand next to each other. So we get x squared y as our new variable. Then I do x squared times negative 8, which is negative 8x squared. Once I have distributed x squared to every term in the opposite parenthesis, I now can do 6 distributed to every term in the outside parenthesis, or opposite parenthesis. 6 times y is 6y, and 6 times negative 8 is negative 48. And from here, none of these terms can be simplified, so that means I am done with x squared y minus 8x squared plus 6y minus 48. So let's do one final problem. And this problem right here is why I don't prefer foiling, because we have a trinomial times a binomial, which means we could distribute these terms backwards, or we can distribute these terms forwards, which is what I'm going to do. So I'm going to look at the first term in the first parenthesis, and I'm going to distribute it to every term in the opposite parenthesis. 3y squared times y squared is 3y to the fourth power. 3y squared times negative 6 is negative 18y squared. Now the 3y squared has distributed to every term, so I move to the negative 4y, and I distribute that to every term in the next parenthesis. Negative 4y squared times, or y times y squared is negative 4y cubed. Negative 4y times negative 6 is positive 24y. Now, I have done 2 of the 3 terms, so I have to do one more term, which I don't really have a lot of room, so I'm just going to write it real small over the top here. And so I get 5 times y squared, which is 5y squared. And then I do 5 times negative 6, which is negative 30. And I got a whole mess here, okay? In order to simplify my answer, I want to just simply start on the left and see if there's any term that can be combined with 3y to the fourth. I don't see anything, so I just write 3y to the fourth power. Now, though, I have negative 18y squared, and I have a y squared right there. Negative 18 plus 5 is negative 13y squared. Then I have 4y cubed, cannot be combined. 24y cannot be combined. And negative 30 cannot be combined. And you notice I'm not writing this in descending order. A lot of times, if the directions do not specify, you do not have to write in descending order. I will tell you, though, IXL will frequently not say you have to write in descending order, but will count it wrong if you don't. So be very cautious as you work on more examples of foiling or the double distributive property. As always, if you have any questions,